Oh yeah, we all know what that means. If that music slowly fades out, that can only mean one thing, and it means exactly that one thing. It's time for me to keep my throat lubricated, to keep talking to you. A wonderful evening, good morning, noon, high noon, late noon, midnight, whatever it is that your time zone currently is whenever you're watching this, either if it's right now or maybe later on YouTube. So hello, dear friends, followers, subscribers on Twitch, subscribers on YouTube, and all the random people who might stumble upon this asking themselves, what the heck is going on here? And that's a good question. What's going on here? Last time there was something going on. Last time we started, the time before last time we started shooting. We made a prefab, we spawned that, we made it move, and we called it projectile. So a moving something that's called a projectile, basically that's shooting. And that's what we did. We spawned that thing, we shoot it with our super sophisticated player model thingy there. We shoot it around, and at first our projectiles, they went into infinity and beyond. They never gave up. They never surrendered. They went on and on into infinity until we couldn't see them anymore, but they were still there. They were still executing code. They were still costing us precious processor time, or otherwise known as performance. And we didn't want that. So what we did last time is we tweaked it a bit. We implemented a cooldown, so you're not shooting one projectile per frame, but like one per second or one every 2 seconds. Whatever your heart's content is, you can change the value to whatever you like. And we also took care of the projectiles disappearing, the game objects and everything attached to them being destroyed. So essentially giving up and freeing up the resources again that they have been eaten up. So, we only had a handful of projectiles in the scene, and not a growing list of projectiles that eventually started to cost us real performance. So yeah, that's all the neat things we did last time. If you missed that, feel free to watch for as long as it exists, the VOD on Twitch, or for as long as YouTube exists, watch the recording on YouTube, because we're archiving all of this on YouTube. So even when the Twitch VODs are gone, everything will be available on YouTube. If you're actually currently just watching this on YouTube, you already know this because you're watching this on YouTube. So it's kind of obvious that these things are recorded and preserved at YouTube forever. We are not intending to delete them. No. That's not our plan. So, what's the plan for today? The plan is now that we can shoot, let's make it to shoot at something. And if we shoot at something, we should not forget to say hi to Avari. A wonderful evening to you. Hi there. And another thing that we do when we are shooting around is we want to hit stuff. And we can do this. We can put object in the scene, and our projectiles, they kind of technically they are already hitting these things, but they are going straight through, and then they're continuing and keep going until they are destroyed because they are out of view of the camera. So yeah, today we're going to be taking a look at a fancy thing that in the game dev scene is known as collision detection. We want to detect when things collide to then act upon this collision. Yeah, like when the projectile collides or hits an enemy, we would like that enemy to go poof and vanish into pure nothingness. That will be nice. Yep, and that's what we're going to be doing today. Right. This will be pretty chill. This will be pretty cool because there's not that much to do. So I try to talk to you guys to stretch this out so we actually have a decent amount of time again can spend with each other tonight. So I would say, without any further ado, let's get started, shall we? Oh, yeah. And you're getting already a coffee. Coffee is good. Coffee is a wonderful thing. That's what you need. I don't have coffee. I already used up all my coffee for today. At least the one I made. But I still have some lubricant left. I already pre-lubricated my throat. So, depending on how things go, we might need to do a little itsy-bitsy tiny short break so I can construct some more lubrication for my throat. So instead of going, I go like blah blah. Yes, that's the plan. You serve cold brew there. It's so good. Yeah, that sounds good. Yeah, I had my coffee today. I can't function without coffee. This is no can do. A coworker of mine in my previous job once made the fatal mistake of asking me something before I had my first cup of coffee. He then didn't speak to me for a whole week. and this is actually kind of cute. I really had to laugh at this and was really happy to then answer the question, because he again had a situation where very early in the morning, pretty much the first thing, he had a super important question that he wanted to ask me. But he knew what happens when I don't have my first coffee. So what he did, and this is really cute. I really like this. He got a cup of coffee. He came to my place, and keeping a safe distance, he put the cup of coffee right in front of me, backed up a step, and said, "I have a question." This is so nice. Yeah. Well, we then had a cup of coffee together. I answered his question, and yeah, that was cute. That was nice. I really enjoyed that one. Also, you're already trying to wrapping your head around how to do all this collision-y stuffy. You'll be surprised how easy it actually is. It's so easy. I'm not really sure I'll be able to fill 2 hours with it today, because it's really that easy. So we'll do we do a bit more fancy things. So first, when we have the collision, we're going to be fancying it up a bit with detecting what it is that we hit. Like, did we hit the player? Did we hit an enemy? Or or has the enemy been hit by a projectile, or has the enemy hit by the player bouncing into the enemy? We're going to be detecting these things. So that'll be quite fun. So if programmer coffee level equals 0, yes, then fill programmer exactly. If that's not possible, then run for your life. Yeah, exactly. This is why sometimes at more businessy events that are not like super serious, like where it can be a bit crazy, like I usually am. I actually like my job description. I like to put into the job description field coffee to code converter. Yeah, this is actually what I like to put into my job description field. I'm a coffee to code converter. You input coffee and I output code. This is what I do. Because actually, without coffee, there's no code. It doesn't work. It's funny like that. Yeah. So this is look at this. This is a bit of what we did last time. This is our spawn projectile. This is blah blah yada yada. What is it all we do? Oh yeah, and see, here's the cooldown. And somewhere we also got where did we put the destruction, the destroytion? Where did we put that? Where did we put the, if out of camera, then then go away. Oh, maybe in the projector controller. I was currently this is our movement controller, which is kind of I should have named this player controller, because this is basically all the player stuff. So this is really terribly named. We should maybe I'm not sure if we rename this, because then everything breaks and we have to change it everywhere. So we just keep it at that. We'll just make separate, and then we're going to be doing this anyways, because we've said so many times, we like clean code. So one thing we're going to be doing is we're creating a separate component for pretty much everything. We're creating a component that deals with the collision stuff and health points, because we're giving these things health points. We're not just going, we're doing this the fancy route. We're not doing like, it collided, go boom. Nah, we're doing it with health points. So each time they collide, they're going to be subtracting health points from each other. And only when the health points are 0, it goes kaboom. Naming conventions. Yes, naming conventions are super important. I've said this a few times. The code I'm showing you, I'm demonstrating you here, is not always best practice. Actually, as you can see with all those yellow squiggly lines, is quite often it's not, because this is only for demonstration purpose. This is not how you would do it in an actual production project, where I'm just demonstrating things here, how they are done. And we already talked last year when we had our series on Unreal Engine. We already talked in some depth about best practices. And feel free to watch that. And if you have any questions, there's for once there's a lot of coding style guides out there. Every good IDE comes with a predefined coding style, and you should adhere to that. Like my IDE, the Rider IDE I'm using here, it tells me all of these things. Like when this, if this would be actual production code, I mentioned this last time, and I think even the time before and before, I would try to get rid of these yellow squiggly lines, because you do not want that. You can ignore the green ones to a certain degree, because they are only suggestions. They are like, okay, you can do it like that, but maybe you want to do it differently, and we decided, I do not want to do it differently. This is exactly how I want to do it. So the green ones, they're okay. If you're super pedantic, even try to get rid of those. But when they start getting yellow, you really should get rid of this. So a good IDE really helps you writing good code, because especially in the case of Rider, it knows so many conventions and things to do, and it also knows about all the special things of Unity. So it doesn't only know the standard C# stuff, it also knows all the special things that have to do with Unity. So it tells you, you shouldn't do it that way, do it differently. With the transform position, we actually did it because we had it up here. We had the same thing. We wanted to change the position, and we accessed this transform.position several times, like we do here, like the X, Y, and Z value. And it gave us the yellow squiggly line and said, oh, come on, accessing transform repeatedly, that's inefficient. This is not cool. And then we changed it. So we remembered the transform position in a local variable, and then we just used that one, which performance-wise and everything else is a bit more efficient and a bit more clean. So you can see there's no yellow lines in this method. And you should listen to your IDE. If your IDE suggests you doing stuff a better way, then you actually should do it. But again, this is just for demonstration, so we're going to stick with this, or else this would completely blow up and overcomplicate this tutorial series. And we want to keep it simple, right? Right. So, where do we start? We start by going back into the Unity editor. And just to check what we can do currently, we can, if it ever starts, we can, we can shoot. I think we have What's our current 0.5? Okay, so we are shooting every half second. We're going to be shooting a projectile. And now we need something to shoot at. And you know my artistic style. You already know how I created this thing with you. So let's create a few enemies. And you know what? Let's make the enemy a prefab. We've talked about prefabs before at the beginning, what they are, how they work. So let's make an enemy prefab. So at first I will create a sphere, because why not? And that should actually be it. I don't want to make things too complicated, so we keep our enemy. Sorry. There goes the lubricant. We call this thing enemy. So it's not enemy number 1, because there will be lots of enemies later on. So this is going to be our enemy. And there's not much to it. Or we could add something like, okay, let me move this someplace else. Let's make this a bit more visually appealing, pleasing, nice. You know what I mean? Let's do a capsule and let's rotate that like so. Oh yeah. Wow, what the? Okay, but it's that value I want to do. So let's rotate this 90 degrees. Let's make this, I don't know, is 0.1 too small? Yeah, 0.1 is too small. How about 0.2, 0.3, 0.4? Yeah, 0.4 looks, 0.3. And this is, I don't know, 0.7? How does that look like? I mean, look at that. Isn't that a beauty? Look at our enemy. What a beautiful enemy. That's cool, right? So, we call what do we call? We call this flaps, because, I don't know, I think flaps is a nice name, and it looks like it's flapping away. So, let's call it just that. And let's make a prefab. So again, how do we make a prefab out of something we've put into our scene? At first, because let me put this to 0, so that's what it actually saves as default. We just dragged this down here into our assets. I made a neat and tidy prefabs folder. So there it is, and we can delete this one because now we have a prefab called enemy. And we can do two things with that now. We can either spawn this programmatically, like we do with our projectiles when we shoot. Our code spawns or creates an instance of this prefab in the scene, and then we can shoot. So we could maybe make something like an enemy spawner, and that thing just drops us random enemies. So once we've shot them all, there will be new ones. We might do this maybe in the last episode when we have some time, when you just don't have that many questions and I'm out of stuff to rant about. We might actually do this. But for now, we'll just be placing them manually into the scene, which we will be doing by just dragging our prefab back into the scene and then just placing them wherever we want. But there's one thing we first need to do. So I'm going to delete this again, because we want to deal with the collision. So we go back into, no, we cannot not back into our code. First, we need to create a new script, because let's make a separate component for this. And I'm going to be calling this, because this time I thought a bit ahead and thought, okay, what we're going to do, how are we going to do it? I'm going to be calling this health component. Because this is the component that tracks how many health points our object has, if it's been hit by something, and if it is, then, well, we see that we can deal damage or things like that. So let's open up our freshly created health component. We already know about the start and update function, so let me just delete them out of here because we don't need them at the moment. So yeah, I said this thing is gonna be taking care of tracking how many health points the object that this component is attached to has. And if the health points drop to 0 or below, the object will be destroyed. So the first thing we need to know is how many health points does the object have. And again, there is one of the many holy rules, no hard-coded values. So the first thing that we do, and we've done this plenty of times before, so you might recognize this and know what it does, we create a serialized field. And that is, of course, private. And it'll be an integer, and the integer will be health points. And by default, give this a default. Default health points is, I don't know, 100. Is 100 a good? Yeah, 100 is a good value, all right? So let's make this 100 health points. And now we need another thing. This is just a prerequisite. This is not, we're not at the actual collision stuff yet. This is just a bit of prerequisite what we're going to do, because we're going to be dealing with the health points. So another thing is now we need a public method, because this one's supposed to be called from the outside, as you will see later. It returns a nothing, and we call this in, if I detect in inflict damage, because that's our function that we're going to be calling if something hit this object. That other something knows how much damage it deals. And it will call our inflict damage method and tell us, hey, I just did X amount damage to you. And now you might already be asking, wait, time out, break. The other thing is calling the method here, but how? Just stick with me for a minute, or 5, or 10, let's see. Because we're gonna be seeing this, and it's so easy. And this is the neat thing when working with engines, because the engines they just take care of pretty much everything. It's so easy to then just call from the other object that bounced into this one to call this and then actually cause the damage. But first off, we need to know how much damage. So this is damage, right? What we're gonna do is we subtract from our health points the amount of damage dealt, and then we're just gonna be checking if our health points, after we've subtracted them, if they are smaller or equal to 0, because this means we run out of health points, we're done, or supposed to be dead, and we're not doing any fancy stuff. If you're doing this in a production project, you can now you can spawn explosions and particle effects and do many neat little nice things. Next week we're going to be looking at awarding points to the player. But this is something for next week. Next week we're going to be talking a bit about how to create UI, how the UI in Unity works. We'll be adding stuff to this to award points for being destroyed and stuff. We're not doing this. So for now, all we do, if my typing works, cool. We just say destroy game object. We already know this. This we know from last week when we took care of our projectiles and we said, okay, look, we have certain conditions. Like here, right? We have the set of conditions, and if those conditions are met, we want to get rid of the object like it never existed. And what you do is you call destroy on a game object that you want to destroy. I mean, the name's the deal. You're destroying this game object. You're completely throwing it away. It's like it never existed. And of course, we need a reference to the game object we want to destroy. And if we want to destroy the game object this code is currently running on, because remember, these things, they are mono behaviors. And mono behaviors are components you can put onto a game object. Like, see, here's our movement component script. It's this one, or for the player projectile, we have our player projectile controller script here, and we attach this to the player projectile object. So the code basically runs on or for this object. And Unity gives us a reference every time we have such a mono behavior component that's attached to an object and running for this object. We have a direct reference to this game object simply in game object. The long way of writing this for those of you who know object-oriented programming a bit better would be this, literally this, because this is a reference to ourselves, to our player projectile controller class. But since it inherits everything that mono behavior has, and mono behavior has a property or a field called game object that contains the reference to the object we're running for. So yeah, this is the reference to our own object that we're currently running for. We're going to be using references for the other game object in a short while, in a very little time. So yeah, this is our own, and if our I need some lubrication here. Okay, so if the health points for this object, because this code runs for one single object, and when the health points we're tracking for this object, when they go below 0 or equal to 0, it shall go kaboof. It's gone because it's destroyed. So we just destroyed. It will vanish like it's never been there. So that's the prerequisites. And now comes the interesting part. How do we detect that there is a collision, that something bounced into something else? And how can we then call this inflict damage on the other object to actually tell it, hey, I made you ouchie ouch. So the first thing we do, there's two things we do first. We have our newly created health component, and I will attach this to our enemy because we want to track the health for this enemy. So I'll just drag my health. Either I just drag it onto the object here in my asset folder, but then it attaches it to the bottom of this list, and I want to have easy access, so I manually drag it up here because this is where I want to place it, because you can reorder these components. These are all the components that are attached to this object, and you can rearrange them. You can drag them around. The only thing you can't drag, I think, is the transform. You can't put anything. Yeah, you can't put anything in front of the transform. The transform is always the first one, but the other ones, like, see, if I want the mesh filter for that thing for whatever reason I want it there, you can rearrange them. And likewise, you can, when you just drag the component onto here, you can just drag it to the slot where you want it. And I want our own components that we're going to be working with at the top, so it's easier to access them. If I don't know, your workflow says, yeah, I usually scroll down to the bottom and look for my stuff there, that's perfectly fine. You can place them wherever you want. And you can already see one component that we have. Remember, our enemy. Oh yeah, and now we can drag two of these. Let's drag two of these into this scene. Let's drag them into the scene, and give them a bit more better names. So, oops. This is enemy 1, and this is enemy 2. And let's move them a bit. Okay, I need to zoom out here a bit, like so. And like there, and let's tidy up those numbers. because OCD much, so this is 5.0. Oh, look at that. By accident, I hit 3.14. 15982. And that's as far as I can go. That's as far as I know them. Now, let's make this a solid 3. This is 0. This is perfect. Let's make this one exactly on the other side. So this is 5 here and 3 there. So we got 2 nice enemies to the sides of our starting point of the player. And we have our health component on here. And where we can also, this is why we made this a serialized field, because if we want to change the value of how much health points the enemy has, we can just set it here. We can just give this enemy basically as much or as little health points we want. And if you now take a look at this enemy, you can see we already have a component attached to it that's called Sphere Collider. Let's take that apart. Let's start from the back to the to the front. So there it says something about collider, and we want to detect collisions. So that collider thing sounds like exactly what we already need. Need. The first need with 2 E's, the second one with EA. And I'm not talking about Electronic Arts or Early Access. So this is pretty cool, because this is something we need. We need a collider because the collider defines what the area is. Where does collision happen? The most simplest one is a box collider. Or I think the sphere collider might even be more simpler, because the sphere collider just has a radius. The box collider actually is a box. So it defines an area that once another object, also equipped with a collider, enters this area. So when 2 colliders overlap, a collision is happening. So let's check our player. And our player cube down here has a box collider. So when these colliders, when the box collider of the player and the sphere collider of the sphere, when the areas they define, when they overlap, we have a collision. And that's basically how collision detection works. But there's one more thing that Unity needs for collision detection actually to work properly. And we just add this because, well, it needs it. So we hit add component. And then we look for, it's because I tried a few things out. You might, when you hit add component, it might be empty. You want to be looking for rigid body. So our RIG typed into the search field. And let me see if I can grab the old magnifier. So this might be when we hit add component, this might be the window that you're presented with. And if you know where it is, you can click your way through and find whatever you're looking for. But we also have this search field, so we do RIG, and we got the rigid body. There's also a rigid body 2D. But, well, as the name implies, that's if you do 2D stuff. We're doing 3D. So we're taking the rigid body without any suffixes, because that's the 3D one. So we just hit that, and congratulations, we just added a new component to our enemy, which is the rigid body. And it's actually, I actually did this because this is a prefab. I'm going to be removing this again because we'll be adding this to our prefab. Because what I just did is I only added the component to this instance of the prefab that's currently sitting in the scene. But I want all my enemies to have this rigid body, because all my enemies are supposed to properly detect collision. So I'm going to be selecting my prefab here, and I'm doing the very same thing. I'm adding this component, And if everything worked, yes. See enemy 1. If I click on enemy 1, I have my rigid body component. And if I click on enemy 2, it's there as well. Perfectly fine. Now there's one more thing. Well, actually, there's two more things, but the second thing I will show you when it happens. And then we see, oh, that's not what we want. What can we do against that? So you see, we have this is trigger option in the collider, in the sphere collider. We have this is trigger, and it's currently not checked. And we do want to check this because the difference is when this is not set, since we have a rigid body on this, Unity actually applies physics to our objects. And if we have this is trigger not set like is the default, when the objects collide, Unity actually calculates the physics that then take place. Like you have a ball here, you have here a ball, and you have another ball that's coming in, and it's hitting this ball. So depending on the size and the mass, either this ball then goes away, or maybe they bounce off each other, but they interact with each other. Just like if you have marbles or dice on your table, and you're just throwing them at each other. If the one hits the other one flings away, and physics is happening, Newton's laws and physics laws, and I don't know, the laws of general relativity and special relativity, and eventually everything collapses into a black hole. And this is not what we want, because we do not want when these objects, when they hit each other, we do not want the physics stuff to happen. Yes, I'm German. Yes, you might be able to hear this. I'm sorry for that. I'm trying to do my best. But I'm German. Yeah, I'm trying to be international here. So, yeah. But hi, greetings go out. A wonderful evening. Yeah, is it evening? The sun is still rather high. The days are getting longer again. I like this. So we do not want all the physics stuff to happen. We only want to detect, to know that a collision happened. We do not want the engine to actually act upon it. So this is trigger thing. When we check this, the engine then just considers this a trigger collision. So when the objects collide, it won't actually calculate all the actual physics that happen when two objects, collide with each other or bounce into each other. But it will just call a function, a method on our class that tells us, hey, so by the way, you wanted to know when something collided. Yeah, something just collided. Yeah, go with it. So, this is something we definitely want. This is on all the objects that we want to use the collision detection just to detect if something bounced into each other. And we do not want actual physics to be calculated. We set this as a trigger. And since we did this again on the prefab, you see, no matter if I select enemy 1 or enemy 2, it's properly set. So now it's time to go back into our code. And we have the enemy, we have it supplied with our health component. And our health component will also deal with detecting if there's damage to be inflicted. So again, we just create, because if we inflict damage to someone else, we want to know how much. And we again make this a serialized sphere. This is again a lovely integer. And this is damage dealt. And that thing by default causes, 25. It causes 25 damage when it hits something. And now is where the magic starts, because we have everything properly set up. We set the is trigger option on the collider, and we added the rigid body for Unity to be able to properly detect all the collisions. And now Unity gives us a neat little function that is, if I not completely mistype it, there's quite some. We have on trigger enter, we have on trigger exit, we have on trigger stay, and we have the 2D variants of them. And we're not dealing with particles at the moment. So on trigger enter is when a collision starts. This is called on the frame, on the first frame where, remember I said a collision, by definition, a collision occurs when the two areas that are defined by the collider, when they overlap, then we have a collision. And on the first frame where this is the case, on the first frame where these two collider areas overlap, Unity calls us the on trigger enter, because we're entering a collided state. And the other way around, when the objects move away from each other, on the first frame where those collider areas are not overlapping again, we're getting on trigger exit. And I'm not 100% sure, this is just an educated guess. I think every frame that we're still colliding, we get on trigger stay. But this is just, but wait, there's on trigger stay is called once per physics update for every collider that is touching the trigger. Yeah. So this is basically if we're still colliding and we haven't destroyed ourselves yet, and we've collided before and we're still colliding, we get the on trigger stay. So we are interested in the on trigger enter because we want to know when two things start colliding. That's the thing that currently is of interest. And auto-completion to the rescue. Bam, I just hit enter on this and I have the complete, without having to remember it, I have the complete prototype, the complete signature of this method, which is private. It's only called inside this class. It does not return anything. The name is predefined. We cannot rename this. It has to be this name or else Unity will not find this method and will not call it. And this is the most interesting part because we're getting a direct reference to the collider of the other object. Important distinction, it's the collider of the other object. It's not the other object, but we can get a reference to the other game object quite easy because from the reference to the collider of the other object, we can just say .gameObject. And now we have a reference to the other game object. And we can do everything with that we can do with game objects. Like destroy it, but that's too easy because we want to inflict damage. So now we have everything we need. We have a method that's called when the collision starts. And we have a direct reference to the collider of the other one we just collided with. From where we can also get a reference to the game object and then everything else. So what we want to do is, I'm not sure, have we done this last week? Yeah. We've done this last week with the camera because remember last week when we wanted to see if our projectile is still in the visible area of the camera, we needed to get the camera, or to be more precise, we needed to get the camera component of the game object that basically is our camera. So we use this get component on the game object in the scene. That's our camera. Here's this is just an empty game object, but it has this camera component attached to it. And we just got a reference to this object. And then we got the camera component from this object because we wanted to call functionality that the camera component offers us. And what we want to do now is we again want to call functionality that the component of the other guy, of the other game object, offers us the inflict damage, to be precise. So what we're going to do is we create a variable that's of type health component, because we want to get the health component of the other object, so we can then call a method on that object to actually inflict the damage. So our variable needs to be of type health component, and we call this the other health component. Oh, that's a decent name. And again, as we did last week with the camera, we used get component, and since we, from the other collider, we get a direct reference to the game object it's attached to, and then we can call get component on the game object, just like we did with the camera game object last week, only that now we do not want to get a camera component because our enemies don't have a camera component on them yet. That would be interesting. Giving them a camera component and being able to see the game from the view of the other one, from the enemy. That's interesting. Should remember that. Can make something out of that. So what we do is we want to get the component that's of the type health component. And now we just have to save this somewhere. So we just put this into our variable. And yes, we could put this into one line. This is now it tells me it's assigned but never used. When we use it, this squiggly line becomes green because I could put this one immediately into this line, but we don't for now. Just because, I don't know, reasons. Just because we don't. So now we do have a direct reference to the health component that's on the other object that we're just collided with. And now we can do something. Now we can say, all right, the other health component, and let's see what the auto completion offers us if I hit the dot. And yeah, I'm not seeing my... Yeah, I was hoping for a bit more obvious, but anyways, there it is. See, here's our inflict damage method. This one. This might at first be a bit confusing because when I now call this inflict damage, you might think I'm calling this one up here, and technically, yeah, I'm calling this method, but I'm calling it on the instance of the other object. I'm not calling it from here, so I'm not dealing the damage to myself. Since this class is instantiated several times on all of our enemies or wherever we else put them, because this is why we make this a component, so we can put this onto other things. We're calling this inflict damage on the other guy, not on ourselves. And the amount of damage, it now wants the amount of damage, and we say this, we have a value here, how much damage we're dealing. Oh, we're gonna just say damage dealt. Also, since we just bounced into the object, I mean this is an enemy. The enemy itself usually doesn't deal damage because it deals damage when it shoots at you, but then it's the projectile of the enemy that deals the damage to you. So when you get damage dealt by the enemy, it's because you bumped into it. And that means that we have to raise this value on the enemies. But we can't do this here. We can do this in our prefab. We can say, if you ram the enemy, if you crash into the enemy with your player thing or with whatever else, this deals 1,000 points of damage. Because, I mean, look at it. You're not being hit by a bullet. You're hit by a truck. And if the truck collides with you or you collide with a truck, that does quite more ouchie than being hit by the bullet. But, well, it depends on where the bullet hits you. But you get my point, right? I need to lubricate my throat a bit. All right. So we can leave this at 25 here because this is only the default for this class. And this class is currently attached to our enemies. So when we bounce into the enemy, this really deals us some damage, because being hit by a truck. Fortunately, I've never been hit by a truck, but I can imagine it's not pleasant. So I think 1,000 health points on damage, that's perfectly fine. Basically, that's it. We now detect when there is a collision, because the on-trigger enter is being called. We get a reference to the other one, and we tell the other one, hey, haha, we just dealt a humongous amount of damage to you. And the inflict damage method that we're calling here then checks if the health points are 0 or lower, and if so, it destroys the game object. So whatever bounced into the enemy is gone. It's destroyed because so much damage. But we want to do damage to the enemy. And again, this is why we made this a separate component, because look at our player projectile. We want the player projectile to do the same thing, to cause damage to whatever it bounces into. Well, and all we have to do is to take our health components that yet now handles all of these things and just drag it. See, I select my player projectile prefab down here, so I get the inspector view with all the components, and you can see we have the sphere collider. Oh, and two important things: we haven't set this to trigger, and we haven't added the rigid body yet. All right. Now we did this, and now we only need our health components. So I can just drag this up here, and I put this below the player projectile controller, because the player projectile controller is our own stuff. We've done this the weeks before. And now we got two own components on our player projectile. We got our player projectile controller that basically takes care of that thing flying forward and being destroyed when it's out of the view of the camera. And now we also have our health component that says, okay, the projectile has 100 health points and it does 25 damage. And it also takes care of dealing of all those trigger events. So just in case, let's save everything and let's see what happens when I hit play. And oh my god, have you seen this? Have you seen that? Here, that's our enemies. Here's our UFOs, our enemy UFOs. And if I hit play, they just fall down. Huh. What happens when I shoot? Okay, the shooting still works. Well, barely. The shooting I mean, this is funny. I mean, look at those projectiles. They start going, but eventually they are falling down again. This is actually funny. And look at that. Look at how they swing and how they bounce into each other. Why do they bounce into each other? I told them to be trigger only. So no idea why they bounce into each other. But this is not the behavior we want. This is not what we want. So we can do and there's also a lot of null pointer references, object reference, not so instant where and how and why. Oh, because okay, yeah, we actually should. Okay, this is cool. This is the nice thing when working with languages like C#, because nothing really breaks, nothing goes kaput. You just get a few error messages because our projectiles bounced into other things that for some reason. Oh no, they did have the collider, but they didn't have our health component attached to them, like. You know, these things we made as trails for the projectiles. It still detects the the collision with them, but they don't have our health components. So this returns null because the health component doesn't exist. And that's a good thing because we should check that. And there's a long and a short way of checking this. One thing is we could see if the other health component is not null. That's the long way. Another way we could do is we could just reduce it to like so. Because null, among a few other things, like the value 0, or an empty, I'm not sure about an empty string, but there's a few things that when you evaluate them as a Boolean value, they evaluate to either false or true. So an integer of 0 evaluates to false, everything else evaluates to true. An object reference evaluates to true when there's actually an object reference in there, like when we actually got a reference to the health component of our counterpart. It will evaluate to true. If there is no health component on the other guy, then this returns get component returns null, and null evaluates to false if tested for a Boolean value. But since we do not want to confuse people too much, we just keep it at the long way. This is just take it or forget it. If it confuses you, forget it. If you say, oh, this is neat, then remember this. So we check if what we got as the other health component, if that's not null. Meaning it actually does have our health component. Then we call the inflict damage on it and everything's cool, because otherwise, well, as we've seen, that doesn't work. So we clear the error log and we start this up again. Yeah, our enemies, again, they all fall down. And then let's see if we see. They still bounce into each other and behave really, really funny. It's funny. Yeah, it's good for a laugh, but it's not how we wanted it. It's not what we want. But at least when they do when they do bounce into each other, see, we're not getting these null pointer references anymore because we've taken care of that. So now we do not want these things falling down. We actually do not want to have any physics on them at all. So what we do is we go into the rigid body component. We do two things. First of all, we disable use gravity, because our enemies, they fall down. Let's only do this. Let's just disable the use gravity on them all. So if I run this now, you can see our enemies are not falling down anymore. That's success, because the physics engine in the background, the physics part of the engine does not calculate gravity. So they're not pulled down by artificial gravity. They are just hanging there in a gravity-less space. But if I shoot at them, well, we can see the collision detection already working, because and actually this is yeah, maybe because we destroy them. Because still, if they bounce into physics, but yeah, see this. Okay, this is here. I can demonstrate this. Look at this. They are still reacting to other objects like they're solid. So there's still physics applied to them. They bounce into solid object and they behave like physics would then behave, or as good as an approximation as you can get in a game engine. So another thing we can do on the rigid body is we can enable the is kinematic. Because the is kinematic thing, if I get the tooltip, I do not get the tooltip. Okay, that's okay, too bad. If we select the is kinematic thing, then we tell Unity, don't bother with all the physics stuff. We're doing this ourselves. We are controlling our object. we have code in place that moves the object to wherever it's supposed to be. Do not bother applying your own physics. Or at least I hope that's what it does, because when I used it to prevent exactly what I just showed you, it worked. So if we shoot now, yeah, see? Now everything works as before. Now everything neatly works. Our projectile does not interact with other objects anymore. It just goes straight through it, because we told Unity, don't bother applying your own physics. We're taking care of everything. We're taking care of the movement. And you can also change this value during runtime. You can access, again, of course, you can access the rigid body component like any other else, and then you can enable or disable the kinematic flag, because sometimes you want objects to just behave with the normal engine physics, and sometimes you say, no, right now I want to animate them myself. Please do not apply any physics. Then you can programmatically temporarily set this flag, and when you're done, re-enable this, and everything's cool. Another thing, just to demonstrate this, if we run this, and then I go to maybe the second enemy, and I enable the use gravity, nothing happens, because we told the engine, don't bother. We are using our own stuff. But if I now remove the iskinematic flag, Unity starts applying its physics to the object, which makes it fall down. And since I did this doing runtime, yeah, I have not destroyed anything that we actually want to use. So, yeah, and we've already seen, before I show you another thing, we've already seen that our collision detection works, because remember, we've set the enemies to where is it? Here. The enemies, they have 100 health points. And our projectiles, they deal 25 damage points. So that means that we should be able to kill each enemy with 4 hits. That should do it. 1, 2, 3, 4. And see? Kaboom. Our projectile vanishes, because look at that. When I just shoot, it just goes up till we don't see it anymore. And even here, it just passes right through. But when I hit the enemy, the projectile goes away, because the enemy also deals the 1000 damage to our projectile, and our projectile also only has like 100. So it's they are dealing damage to each other. It's like when you're hit by a truck, you're doing a bit of damage to the truck as well. Of course, the truck is doing way more damage to you. So let's say a car runs into a tree. It might happen that the tree breaks and falls down, but the car is total as well, because they do damage to each other. The car does damage to the tree, but the tree does also damage to the car, and both a lot to each other. And this is exactly what happens here. Each time when our objects hit, when our projectile hits our enemy, the projectile gets the on trigger enter called and knows, oh, I collided with someone. Let's do 25 damage to them, because we set the projectile to doing 25 damage. The enemy also gets the on trigger called and being told, hey, you just collided with someone. And the enemy then says, oh, great, I gotta deal 1000 damage to you. So the projectile immediately dies. It's kind of one hit because there's just too much damage. But the enemy, it can survive a bit, because it still has a few more hit points. And interestingly enough, now I can't. Okay, and now it goes away. Yeah, I'm not sure why that didn't work, but might be timing. Yeah, well, but in the end it worked. Another thing we could try. just to check out our damage we are dealing. If we say the player projectile now does 50 damage. Well, that's a nice value. It does 50 damage when it hits something. So now we should be able to kill an enemy with just 2 hits. So there's one, and there's another one now. Yeah, okay. And now it's just not working. It might be that the projectile is destroyed before it can. Yeah, see, that's been 2 hits. This might be a timing issue because this is not perfect what we're doing here. It might be that our projectile gets destroyed before it can deal the damage to the enemy. Because in theory, both of these things should happen at once. When the projectile hits the enemy, both of them should get the on trigger enter being called. But it might be that the enemy, and this is a timing issue, and this is actually this is something you have to deal with when doing this, not just for demonstration, but actually doing this for production. And we're doing one more thing today that kind of deals a bit more with this and actually solves this problem. Because what might happen is that let's start the other way around. These things, they can't happen exactly immediately. Because the game by default runs in one thread, in one process. So everything has to happen in order. There's only one thing that can happen at one time. So the on-trigger enters, they are not called simultaneously. One of them is called before the other. And if the timing is good and the on-trigger enter of the projectile is called first, the projectile can do its 25 damage to the enemy. The enemy survives this because it has still enough health points left. Then the on-trigger enter of the enemy is called, which completely destroys the projectile. But if it's the other way around, if the on-trigger enter of the enemy is called first, it inflicts its 1000 points of damage to the projectile, which immediately causes the projectile to self-destruct because it knows, oh boy, my health points are down to 0. And a destroyed object that doesn't exist anymore can't have its on-trigger enter being called. So the enemy got lucky. It didn't get any damage dealt. So that's stuff you actually have to take care of and consider when coding these things. But there's another thing I want to show. Before I show you one way to solve this, there's another thing I want to show you. So let's grab our player cube here and let's give this our health component as well. So now our player also has health points and deals damage when it bounces into stuff. Yeah, let's... No, for the demonstration to work better, I'm going to be setting the health points of the player to 10. And we're going to be setting the speed of our projectile down. We make these projectiles really slow because I want to show you something. So we set the projectile's speed to 1 and we put the lifetime to 100 so they don't self-destruct too soon. Because now look at that. Depending on how your game's built, the following thing might happen. The player shoots several projectiles, and for whatever reason, the player runs into his own projectiles, which might eventually destroy him, because these projectiles, they also deal damage to the player, because remember our code. We're just checking, oh, we got a collision, we're getting the health component of the other one, we're dealing our damage, boom. So that means friendly fire, or self-fire for that matter, Because if I've already restarted this, so maximize this. Gonna be shooting a few of those projectiles. And okay, now I bounced into the enemy. Shouldn't have done that. But you can see, even if the player bounces into the enemy, which is correct, because the enemy is supposed to deal damage to the player. So if the player bounces into the enemy, it's supposed to be destroyed. But the player's not supposed to be destroyed when he bounces into his own projectiles. Not sure if this was the enemy there is a bit in the way. Let me see if I can fire them a bit more clever. Like I'm just firing them here. And now I can go up this way. And now when the projectile hit the player, they also deal damage to the player and destroy it. And this is something we do not want. Well, sometimes, depending on the game, you might want this. But right now, we don't. So let's fix this. And we can easily fix this with, again, something that the engine just offers us. It's just there. It's just functionality we have to use. And when I click on my player again, you can see that up here, and let me magnify this a bit again. Up here, we have an option tag. And currently, it's untagged. And if I click on this, there's already a list with things I can tag this object with. And I also have the option of adding my own tags. So since this is our player, it's perfectly fine. See, we already have predefined a player tag. Let's use this. So now this object is tagged as player. And now let's go to the enemies and let's also tag them. But we don't have anything that fits, so we just say add tag. And the list is empty. We just hit the little plus button here, and this is enemy. Save. And I think I can also get rid of the magnifier again. And once we're here, we just add another one, and we call this player projectile. All right. Okay. So now we have a couple of tags. We can now apply these tags to, we can apply the enemy tag. We can tag our enemies with the enemy tag. And we go to our player projectile. And we tag this with our player projectile tag. Wonderful. And these tags, using these tags, we can determine if we want to do damage or not. We have to make it a teeny tiny little bit more, not really complicated, but we have to add one more thing. Since we only have one health component, we could split this up now. We could split this up in a player health component and an enemy health component, but let's just play with some more of those serialized fields. And let's give us the option to tell the health component what kind of objects it should actually deal damage to. And we're going to be doing this right after a very short break. And yeah, don't run away. It's, 2 minutes, maybe 3. And we'll be right back, and we will be taking a look at how to use those tags to determine if we're actually supposed to deal damage or if we don't. So the player projectiles, they do hurt the enemies, but they don't hurt the player. Don't run away. Be right back. Let it be 2 minutes, maybe 3. See you after the break. When I find the button for it. There it is. And we're back. So, welcome back, everyone. And as promised, first let me lubricate my throat a bit more. Wonderful. So, as promised, before the break, we've set these tags onto our objects. And now let's see what we can do with them. We go back into our code, and we have inside the onTrigger enter, we have the reference to the other collider, where we also get the reference to the other game object. And from this reference, we can also get the tag that we used to tag the object. Just let me check one thing quickly, because we need to, and we can indirectly use the reference to the other one. Wonderful. So all we have to do is, when we know the other one. Okay, this is now a bit, where do you place the if blocks? I'm currently thinking, where do you put it? You know what? We put it here, because if we are not wanting to inflict damage, we don't have to get the health component of the other guy. And getting components, I've talked about this last week, getting components is quite an expensive thing to do. That costs you quite some performance. So only do this when you really, really have to. So let's put an if here. And let's put this into the thing we're ifing. And now we can just check if the other one, that's the reference to the other collider, and the collider already is so nice to provide us with the tag of the other one. So we can just by accessing the tag property of the collider of the other one, what we're getting back is exactly the text, the name of the tag that we use to tag our object with. So what we can do now is, since that's a string, we can use the equals method of a string. We can see if this is an enemy. Enemy. Have I written this right? Yeah, enemy. Yeah, should be, looks weird, but okay. So if the tag of the other one equals enemy, then we do all the things we do so far. Let's try this. Let's Unity recompile this. Retry. And we might see our next issue. So now, when I shoot a few of my projectiles, and I let the player bounce into them, see? The player is not, they move, and not sure if you can see this, but the player, the projectiles, they move right through the player. They do not hurt the player anymore, which is exactly what we wanted. Our projectiles don't hurt the player anymore. Oh, but as we've just seen, they do hurt the enemy. So if I go to here and I shoot the enemy once, it's already gone. And you can see the projectile, it still goes. It still keeps going. The projectile isn't destroyed anymore. So let me restart this and show you another thing. Because even if I bounce with the player into the enemy, that should destroy the player, because the enemy is supposed to deal quite some damage to the player upon collision, nothing happens. And of course nothing happens, because we're checking. Remember, this component is on all of our objects. So all of our objects are executing the same code when checking for the collision stuff. And we're currently only checking if we're hitting an enemy. Now we also want to be able to do damage to the player, or to player projectiles, for that matter. And for this, we need to give our component options to know what it should inflict damage on, because if we now just say, or if this is player, then we do this, or if this also is player projectile, then we're back at square one. If we just check for every possibility, we don't need to check at all. So what we're going to do is we create a couple more serialized fields, and we just make them bools, because why not? And this is damage player. And by default, let's set this to false. Everything. Let's set the defaults to false. So it really only does damage to the things that we actually enable. So damage player projectile or damage enemy. All right. What we do now is, since these are serialized fields, we can edit them. We can change them from the editor. Let me save and compile. Let Unity compile this. And if I now check my enemy here, or let's take the enemy prefab, you see we have these options here. We have these options, we have our health points, we have the damage we're dealing, and now we can choose, do we want to damage the player, do we want to damage player projectiles, and do we want to damage enemies? Pretty neat. All we have to do now is to incorporate this into our if thingies, if I get my IDE back. So we're checking if the tag equals to enemy, and we're supposed to damage enemies. As simple as that. Damage enemy. So now we're checking for two things. We're checking if we did hit an enemy, because we're using the tag to identify what kind of object we just hit. And we check if we did hit an enemy. And we check if we're supposed to damage enemies, because if we want this thing to cause damage to an enemy, we set the check mark, which means this value will be true, so everything will be fine. So if we do not want to damage enemies because the check mark here is not set, this will not evaluate, we're not doing any damage. Other way around, we do want to damage enemies, but we didn't hit an enemy. Again, this doesn't evaluate, and we're not doing any damage. And since we always want to do the same thing, we just expand this a bit. We just put brackets around this one, and for readability, we put this into separate lines. And then we OR this with two more things, because we either want to hit, we want to have hit an enemy and want to damage enemies, or we want to hit a player and we want to damage players, or we want to have hit a player projectile and we want to damage player projectiles. So if either one of these matches, so if either this or that is given, then we're executing all this code because we want to do damage, at least in theory. Let me try this out. So we're going to save this. Unity recompiles. We go to our enemy prefab, and the enemy is supposed to do damage to the player and the projectiles, but not to other enemies. Our player projectile is supposed to do damage to enemies, and enemies only. So we can now just conveniently select what we want to do, where we want to cause damage. And when the player, we can say we want to damage the enemy, because again, the example with the car and the tree, not only the tree totals the car, but the car also does severe damage to the tree. So when our player crashes into an enemy, it also damages the enemy, but it does not do damage to... Oh, you know what? Just to have a bit more variety, let's also do damage to our own projectiles. That means our projectiles don't do damage to us, but we do damage to the projectiles, meaning if we bounce into our own projectiles, we kind of absorb them. They vanish, but we don't. Our player will still continue to live, and, well, we're not damaging the player. So, for demonstration purpose, let's... the health points of the player be quite low, just so we can actually see when the player is destroyed. But when the player bounces into something, it takes quite some damage. So it takes like 100 or something. Excuse me. All right. Okay. Back in business. My lubricant is coming to an end. But that's okay, because we're also coming to an end with what I wanted to show you today. Because if this works, we're basically done. So, have we set everything? Yeah, let's try this. Let's try this out. Let's make this full screen. So, now we can move around with our player. And let's see. I'm going to be shooting a few projectiles here. And okay, the first ones are already hitting the enemy. And see if the player bounces into these projectiles. Let's make a few more here. And if I bounce into these projectiles with my player, the projectiles will go away because I damage them. But they are no longer damaging me. But they are damaging the enemy, or at least I hope they do. And this might be our timing thing. Yeah, this is the timing issue I talked before. Because they're doing damage to both. So there's something to think about if you want to do this in a production project. You have to do something to resolve this race condition. And if I now bounce with my player into the enemy, kaboom! Well, they're both gone. That's interesting. Oh yeah, because the enemy only has 100 points. Because let's pull the damage of the player a bit down. Let's say the player only does 80 damage when he bounces into something. Right? So now, when I bounce with the player into the enemy, player's gone because didn't survive all the damage, but the enemy now survived all the damage. Maybe I should put a shortcut or so to respawn the player. However, if we damage the enemy first, and let's see that we maybe have a timing chance of it actually having gotten damage, they both, yeah, okay, it didn't. Yeah, this is the timing issue because they are doing both. We could resolve this by just not having, but then they would go straight through. But for demonstration purpose, but then they keep triggering. Yeah, well, okay, this is something you can come up with a solution for yourself. So you see, we have a bit of a timing issue. I explained this before the break. What's happening, why sometimes we need a few more projectiles to actually kill the enemy. But basically, it works. Except for this little timing issue, it works. We have our player. We can shoot. Our player can bounce into his own projectiles without taking any damage. And for some super weird reason, even the projectiles... So what? No, there they went. I don't know. For some reason, even the projectiles now survived. Yeah, see? But there they are going. And we can shoot enemies. We can make the enemies kaput. Our wonderful enemies. And oh, this one's resilient. This takes quite a few projectiles to get this beast down. Yeah, we definitely should take care of this timing issue. So we have a bit more precise. Well, we know what's going on. Basically, it works. Everything's cool. So that's collision for you. That's how you do collisions, how you detect collisions, how you can act and react to collisions. All you have to do is make sure your object has a collider, and it doesn't have to. A sphere doesn't have to have a sphere collider. You could also create a sphere with a cube collider, or a cube with a sphere collider, or a super sophisticated 3D model of a spaceship, and you give it a sphere or a cube collider. And I think there's even mesh colliders where you can give like super sophisticated meshes, so you have kind of pixel perfect collision, but that's gonna cost you performance. That's going to be costing a lot of performance. So make sure your object has a collider of the type you need that specifies the area that you want to check for collision. The best you can also change all these things. We just let them with the default because that just worked. Then you need the rigid body. And don't forget to at least set kinematic, maybe even disable use gravity so they don't just fall down. But having set is kinematic, since the whole physics is not applied anymore, which also saves you a lot of performance, by the way. The gravity isn't applied anymore, but I set them both to what I want them. So yeah, you need your collider, you need the rigid body. The collider needs to be set as trigger to not actually cause all the physics chaos. Then the gravity and the kinematic of the rigid body, and then in your code, on your object that has the collider and the rigid body, you can use the onTriggerEnter, onTriggerExit, and onTriggerStay methods. You just have to define them. If they exist, Unity will call them for you, and you can put your implementation in there of whatever you want to do when you detect a collision. It doesn't have to be damage dealt. Another thing is you could use a trigger collision to open a door. Like imagine you have a level, and if you're standing in front of a door, the door is supposed to open. You know, these Star Trek futuristic supermarket sliding doors or whatever. That you have maybe a cube collider, and when you enter this collider, when you enter the area that the door is affected by, the door opens, and when you leave the area, the door closes again. Like in Star Trek or most supermarkets with automatic sliding doors. That's another use case where you can use these trigger collisions, or basically the sky's the limit for whatever you want to use them. You can. And if you want to differentiate, if you need to, I mean, of course you can implement your own stuff. What we could have done there's always a lot of ways to get to the same goal. And usually most of the ways are right, or very few are wrong. So we could also have given our health component another serialized field where we can define the type of what type of thing this is, and then have to check against these check marks if you want to damage this or not. But the tag thing is something that Unity offers us. It's a built-in engine functionality. You can do this with any object. You can just say, yeah, you can tag this. Unfortunately, you can only tag this with one tag. I personally would have liked it if you could apply multiple tags to one object. So like it's an enemy, it's a projectile, it's this or that, so you can differentiate, filter a bit more. But well, you only have the one tag. If you want to have a more sophisticated means of detecting what that object is, you have to to build something on. maybe write your own tag component, slap that on there, and then you can tag this with whatever you want and as many tags as you want. But this is one neat way that the engine offers, is to add as many tags as we like and assign one tag to each game object, because we can then just query this. We can just see, okay, what's the tag of this? Does this match with the object we want to be acting on? And do all these neat things. Well, that pretty much concludes today's session of doing collision in Unity. Let me just for the looks. Well, this almost looks like a face. These could also be eyes. But I like our UFOs. I mean, they really look like UFOs. Huh? These huge bulky things with these flaps on the side. Yeah, good design. So, thanks a lot for watching. Thanks for being with me. And I hope you enjoyed it. I hope you could take something away from this and it actually helped you in furthering your understanding of Unity, how to do stuff. And see you next time. Next time we're going to be doing a bit UI, because when the player actually destroys these enemies, he wants to get score, and the score needs to be displayed so the player knows how much score we have. And maybe we even implement a small enemy spawner so that we don't only have those two, because that's kind of a short game. So there's randomly spawned enemies and stuff like that. And maybe if we even make an enemy controller that makes them move down a bit or something. Yeah, let's see. That's all the interesting things, adventures and quests of next time. Thanks a lot for this time. See you around. Bye bye and take care.